Hello everyone, this is heading 10. In this video, let's learn chapter 7.2, the law of science. We will learn 4 objectives. The first one is law of science. In previous class, we have learned how to solve the right triangle. So that means if we have a right triangle, we solve the 3 angles A, B, C, and the 3 sides A, B, C. And right now, we are learning something to solve the oblique triangle. The oblique means not right triangle. So oblique. That means not right triangle. So there's no angle equals 90 degrees. Right triangle. So let's see. There are 2 kinds of oblique triangle. One is acute triangle. Acute triangle. Just put acute. Another one is obtuse. So acute triangle, just like this kind of triangle. So all the 3 angles, they are acute. The obtuse triangle, that means one of the triangle is greater than 90 degrees and less than 180 degrees. So that's the oblique triangles. Let's see the law of science. The law of science give you the relationship between the A, B, C, the length of the sides, and the angles, sine A, sine B, sine C. We mentioned about that angle A is the opposite of the side A. The angle B is the side of is the opposite of side B, and the angle C is the opposite of the side C. For example, if I have A, B, C, so the lowercase a is here, the length from here to here, and the B, lowercase b, is the opposite of the angle B, and C should be here. So the relationship between the sides and the angle is A over sine A equals B over sine B equals C over sine C. Or you just do the reciprocal, put the sign on the top, sine A over A equals sine B over B equals sine C over C. Okay, let's see SAA or ASA. What's the SAA? S represents side, A represents angle. So SAA means they provide us a side. For example, this is A. They provide the A, and then angle alpha, angle beta. So the order is A, alpha, beta, or SAA. So I can also say if they provide us B, and then AA should be here, here, or here, here. Just means N side and the angle next to the side, and then the angle next to this angle. So the order should be here, or the angle. Oh, see, the order SAA is A angle, angle. Sorry, not A angle, angle. The side angle, angle. Or the opposite way, if I have a side here, angle, angle, side, angle, angle. So the same way to express SAA. So ASA, that means ASA. So angle, side, angle. Okay, let's see. Solve an oblique triangle given SAA. That means the side and the two angles. So solve the triangle with A equals 31 degrees, C equals 76 degrees, and C equals 19. Round the length of the sides to 1 decimal places. So the textbook could provide us the image that is the angle A, C, and C. So that's SAA. So can we find the B? Yeah, because the angle B equals 180 degrees minus angle A minus angle C. Plug in angle A and angle C's degrees. 180 degrees minus 31 degrees minus 76 degrees. What is that? We can use calculator. Or, so try to use the calculator. 180 minus 31 minus 76 is 73 degrees. And then we know here is the C. Use the formula that's sine. Putting this formula here because the given function has the C and C, the angle C and the length of C. So this part is given, and A is the angle A here. So we are looking for A. So from this expression, if I write it down, A over sine A equals C over sine C. Then that means I can isolate the A. A equals, so multiply by sine A, both sides equals C times sine A. Sine A is what? It's 31, right? So 31 degrees over sine C. Sine C is sine 76 degrees. And can I plug in C in the expression? C is 19. So we put 19 here. And use our calculator, find the result. That's 19 times sine. Make sure the mode is degree mode. So click mode, highlight the degree, hit enter. Second mode, we get out. So 19 times what? Sine 31, close the parentheses, divided by sine 76, close the parentheses. That's 10.085 something. So read the question, round the length of the sides to 1 decimal place. 1 decimal place here. So the number after 0 is 8. So we should keep 10.1 in the answer here. So 10.1. That's A. How about B and C? Because here we found the angle B. So by the formula, C over sine C is given. I can use B over sine B equals C over sine C. We are looking for B. So B equals C times sine B. C is 19. Sine B. Sine B is sine 73 degrees over sine 76 degrees. So it's about 19 times sine 73 degrees divided by sine 76, close the parentheses, hit enter. 18.7. 18.7. So we solved A, B, C, and all the angles. So let's list all the information there. So A equals 31 degrees, B equals 73 degrees, C equals 76 degrees, and A equals 10.1. It's about 10.1, not exactly equals 10.1. B equals 18.7, and C is given as 19. So that's how we found ABC, the angle ABC, and the length ABC. And in the question, I use the sign, the notation, this for angle. So if you have this, that means angle. If you don't have this notation, you should use a capitalized A represent this one is an angle, because the lowercase, they are lengths of the sides. Okay, let's see solving an oblique triangle given A as A. That's if I have angle A as A. A as A, as is in the middle between the two angles. So the triangle is A equals 132 degrees, B equals 28, C equals 8.6.8. So if I see two angles, can I find another angle? Yeah. So angle C, I can use the angle C, or I just put C. It doesn't matter. So 180 degrees minus 132 degrees minus 28 degrees. What is that? So 180 minus 132 minus 28 equals 20. So 20 degrees. So this is the ABC, angle ABC. Let's find, so here is C, here is angle A, and here is angle B, and also we learned the angle C here. That means sine, we can use the sine formula. We use C over sine C equals A over sine A, B over sine B. So A over sine A equals C over sine C. That means, because we know the angle C, angle A, that means that we're looking for A. A equals C times sine A. I can plug in the information. So C equals 6.8. Sine A, that's sine 132 degrees, divided by sine C, that's sine 20 degrees. Use the calculator, that's 6.8 times sine 132, close the parentheses, and then divided by sine 20, close the parentheses, hit enter. So the A is about, keep one decimal place, so 14.8. So next length, I need to find the B, because we have the angle B. We don't have the length. See the B. B equals sine B equals C is 6.80. I'd better just write down the formula. C over sine C. That means B equals C is 6.8 times sine B. Sine B is 28, sine 28 degrees, divided by sine C. Sine C is sine 20 degrees. Use the calculator. 6.8 times sine 28 close parentheses divided by sine 20 degrees close parentheses. That's 9.3. 9.3. So write down the summary. That's A equals 132 degrees, B equals 28 degrees, C equals 20 degrees. Lowercase a is it's about 14.8. B is about 9.3. C equals 6.8 because this is given information. Okay, let's move on to see next part. SSA. So in previous slides, we have learned that ASA, SAA, there are two angles. If we have two angles, that means three angles are given from the question, because if we have two angles, we use 180 minus the sum of these two angles. We found another angles. That means by two given angles, we can find three angles. And also we have one side. That means this a triangle is all set. So we can't say change it to the smaller or bigger the size, I mean, or do some transformation, because three angles are all set. And if one leg or one side is given, so we can't change anything about this this triangle. But if we only have two sides and one angle, so this is ambiguous case because we don't know another two angles. So if the question provides us SSA case, this is ambiguous because it has so many possible cases. So the first case, for example, if they provide us SSA, the S, they are together. These two sides are given, and then the A is here, or the A is here. So I don't know where is the, so I don't know is here or here because it's only give us two sides and one angle next to one of the sides here. Okay, so let's see the example. If the A and the B, the length is set. So here and here, they give us A and B's length, and they give us A's value. So maybe if the A is so short and this is the A is very short segment, so I can rotate the A because the angle here is not given, they only provide the A, so I can rotate the A and the center is C. If the A is so short, there's no intersection with the AB. AB is unknown. I don't know how long of the AB. I don't know how long of the AB. And the A is so short, there's no intersection with the segment A and the ray AB. That means there's no triangle, because triangle means this. So so sides, they have the intersection here at the angle part. If this side has no intersect with another side, that means this is no triangle. We can't create the triangle by this case because A is so short. So let's see another case. So the second case, since in the first part we know if A is given, B is given, the angle is given, the A we just rotate it as a ray and rotate it center as C. If A equals the altitude, that means when we rotate the A, we just have one intersection at the point B, and A equals the altitude. That means, oh, we have one right triangle. This triangle is a right triangle. And another one oblique triangle if the A is very long. And then if we rotate the A center at C, I can go this way or I can go this way. It's okay. So we have only one intercept at the B. So we can create, we can create one triangle. This is oblique triangle. Intersection is here. That means A is greater than B. We have a very long A, and then we can create one oblique triangle. And how about another case? The fourth case, we can create two triangles. So the A is given, B is given, and the angle A is given. And then we just rotate the A, and so we rotate the A. Center at the C. So we have two intersections here. So at here or here. That means we can create two triangles. One triangle is here, here, and here. Another triangle is from here to here to here. So this is an interesting case. So remember, SSA, if we have two sides, that means the case is not that simple like a two-angle case. So let's see how to solve the SSA case in the question. Let's see. Solving a triangle given SSA, one solution. The hint is SSA and one solution. Solve the triangle with A equals 57 degrees, A equals 62, and B is 50. Round the measure of the unknown angles and side to one decimal place. So here is the picture. We have two sides, A and B, and the one angle, 57. So this angle is not between S and S. It's just next to one of the leg. So how to solve this case? So we can use the sine formula. So we have, since A and A, we have A over sine A equals B over sine B. I can continue to write C over sine C, but there's no necessary in this step because A and sine A is given. Oh, sine A is not given, but I know the angle of A. and use calculator find sine A. And B is given is 50. So we are solving sine B. Then we can find the angle here, do the inverse sine. So do the cross multiplication. So A times sine B, B times sine A. We can do this. That means A times sine A equals B times sine A. Oh, sorry, sine B. Here is sine B, cross multiplication. Because A times sine B, B times sine A. And we are looking for sine B. Sine B equals divided by A both sides. That's B sine A over A. And then plug in the information. B is 50. Sine A is 57 degrees. A is 62. Use a calculator. We have 50 times sine 57 degrees divided by 62. It's about, if we keep 4 decimal places, because this is not a final answer. Final answer, we keep 1 decimal places, but in the steps, in our steps, we keep 4 decimals. So 0.6763, 0.6763, sorry. Yes. And then this is the sine B. How about the inverse sine? Because we're looking for the angle B. Angle B equals inverse sine 0.6763. So inverse second sine 0.6763. Close the parentheses. We got it's about 42.555. I can say that's 42.6. It's about 42.6. 42.6. So this is the angle B. If we have the angle B, we can find the C because A is given. So let's see what is this. What is C? C, angle C. I can put angle. It doesn't matter without the angle sign because the capitalized means angle. So 180 degrees minus angle A is 57 degrees minus 42.6 degrees. Don't forget the degree sign. It's about, so C, use a calculator, 180 minus 57 minus 42.6. That's 80.4. 80.4 degrees. So we have the angle C. Can we find the length of C? Yes, of course, because we have A sine A. So we use A over sine A equals C over sine C. That means the lowercase c equals A times sine C over sine A. And plug in the A sine C and sine A. A is 62. Sine C is sine 80.4 degrees. And sine A is sine 57 degrees. And then this 62 times sine 80.4, close the parentheses, divided by sine 57 degrees, close the parentheses. It's about 72.9. 72.9. So this is the length of C. Okay, let's do the summary. That means I put the A here. A equals 57 degrees. B equals, it's about 42.6 degrees. And the C equals, I should put approximately, equals 80.4 degrees. And A equals 62. B equals, it's given is 50. So C is about 72.9. Okay, this is the way how we solve this question. So let's see, solving a triangle given SSA, no solution. So what's the meaning of no solution? That means the C is so small. If I use the C as array, center at B, I rotate the small legs, there's no intersection with CA. That means there's no solution for this triangle. Let's see, why is there's no solution? C is given, the angle C is given, and the length C is given, A is given. That means I can use A over sine A equals C over sine C. So what is sine A? So do the cross multiplication. That means A times this equals C times this. We can get A times sine C equals C times sine A. So if I isolate the A, sine A, I divide it by C both sides. So sine A equals A times sine C over C. The calculator. Okay, maybe we don't need to use calculator. We plug in the number in it first. So A is 15, sine C is sine 39 degrees. C, lowercase c is 6. So you see, 15. Oh, right now I don't know the number here. So let's use a calculator to find the answer. 15 times sine 39, close parentheses, over 6. It's about 1.5 something. For example, 1.57. We have learned this is the sine A. The sine function is like this. I can continue to draw. So the maximum is 1, minimum is -1. And this number is more than the maximum of the sine A. That means that's impossible. So no solution. Because this one, the sine A will never be 1.57 because it needs to be bounced by -1 and 1. This one is too big. No solution for this question. Okay, let's see next one. Solving a triangle given SSA, 2 solutions. The meaning of 2 solutions, that means if I have, do you still remember the graph we talked about? So this angle is given, and then this one, A is given, B is given. This one, I don't know how long of this. I can draw a ray, continue to draw. So this one, the A, I can use the A as a radius and rotate at the C point and rotate the A. So rotate it. I have 2 intersection on this ray, for example, A and A to B. So there are 2 intersections. So this is a triangle, or I can create this triangle. We have 2 cases. So let's see why this question has two cases, and let's solve this oblique triangle. So A is 29. This is A. A equals 7 and B equals 10. Since they only have one angle A, we don't know the angle B and angle C. That means the B and C, there could be an angle for B or C is greater than 90 degrees, or they both less than 90 degrees. So let's see. For the first case, assume alpha B is acute. Assume B is acute. So if B is acute, in the XY plane we have learned, so acute angle is in between 0 and pi over 2. It's in the first quadrant because this is 90. So acute angle B is here. So this is the B. So let's see what is the B. So angle A and A is given. So A over sine A equals B over sine B. We are looking for B. Oh no, sine B. Sorry, sine B. So I just skip some steps. Sine B equals B times sine A over A, and plug in the information. That's equals, let's see, B is 10. So 10 times sine A. Sine A is 29. Divided by A is 7. So it's about 0.6 something. Keep 4 decimals because these are the steps. 6926. 6926. 0.6926. This is the sine B. It's not the angle B. If we are looking for B, angle B, that's the inverse. Okay. It's inverse sine 0.6926. Because the calculator only gave us the inverse sine in this quadrant or this quadrant. Do you still remember the graph? This one and this one for inverse sine. And this one is a positive number. So the angle must be in the first quadrant. So let's see. So second sine inverse 0.6926. And hit enter. Let's see what is that acute angle. Is 43.8. It's about 43.8 degrees. So we have B and angle A. We can find the angle C. C, this is capitalized C, equals 180 degrees minus 29. That's A. Minus B is 43.8. That's about, because here this one is approximate number, so I put approximate to something here. So use 180 minus 29 minus 43.9. That's about 107.2 107.2 degrees. And what's the next step? Let's see. Next step, C. So we need to find the length of C. So A and A is given. So A over sine A equals C over sine C. So we are looking for lowercase c. That means C equals A times sine C over sine A. And then plug in the information. A is 7, Sine C is sine 107.2 degrees over sine A, sine 29. So this one equals 7 times sine 107.2, close parentheses, divided by sine 29 degrees, close parentheses. We have 13.8. It's about 13.8. That means I can write down the summary. That's A equals to 29 degrees. B equals, it's about 43.8 degrees. And angle C equals 107.2 degrees. And lowercase a is about, or not about, that's exactly equals 7. B equals, where is the B? Oh, it's given, it's 10, sorry, it's 10. And C is about 13.8. So this is the first case for the B is acute angle. I hope it's correct. Sine B. Sine B. Do I have any mistake? Let's check. Oh, yes, yes. No mistake. Yeah, there's no mistake. Okay, let's continue to see next part. If B is obtuse, that means greater than 90 degrees and less than 180 degrees. So from the graph, the first graph, we know that A is here. We rotate the A center at C. We also has one possible case that A is, oh, so the B is here. The intersection is here. So how to find the angle ABC? A is given, B and C. So we have learned that from the given information, from the previous step, that we can use this one, solve the B. And we have learned that our calculator only gave us the inverse sine function in first quadrant and the fourth quadrant. Maybe it's positive angle, maybe it's negative angle. And the sine B is a positive number. That means the calculator only gave us the angle in first quadrant. That means the angle B is here. But we have learned that if our B is obtuse, that means we have another case that B can be here. Can be here. In the second quadrant, that's obtuse angle between pi over 2 to pi. So this angle from initial to the right side, this terminal, has the same reference angle B and B here. This one we calculated by our calculator is 43.8. That means here is 43.8. How about obtuse angle B from here to here? That means I need to use pi minus the reference angle 43.8. So go to the next page, I can write it down. this is a case 2. If B is obtuse, B is obtuse. So by the first step, we can, the calculator gave us 43.8. This is a reference angle for the obtuse B. So by the A, the reference angle for B, angle B, this obtuse B. Let's write down. Is 43.8 degrees. That means the real B's value equals 180. That's 2 pi minus 43.8 degrees. Because the reference angle here, I'm looking for the angle from here to here. So we found the B. If we have the B, the angle B, and we know the length of B, and we know the A, so we can find the C and the length of C. That means the C equals, oh, why I didn't put the value here. So use a calculator. 180 minus 43.8. So that's 136.2 degrees. So the angle C equals 180 degrees minus angle A. Angle A is 29 degrees minus 136.2 degrees. It's about 180 minus 29 minus 136.2. That's 14.8 degrees. So we have learned the C. And A over sine A equals C over sine C. So we know the sine C because sine 14.8 is easily to be found from the calculator. So we are looking for C. So the C here equals C here equals A times sine C over sine A. And plug in the information. A is 7, sine C is sine 14.8 degrees, and the sine A is sine 29. And plug in the information in the calculator. 7 point sine 14.8 degrees divided by sine 29. Close the parentheses, hit enter. That's 3.7 if we just keep one decimal place. That's about 3.7. Okay, we can do the summary. That's A equals 29 degrees. Angle B equals, it's about 136.2 degrees. And angle C equals 14.8 degrees. And A equals 7, B equals 10, and C is about 3.7. So that's a solution for this one. There are two cases. One case, that's B is acute angle, and another one is B is obtuse angle. Okay, let's move on to see compute the area of triangle given SAS. SAS, that's we have S, the give one side is given, and then angle in between alpha and S. So S, and then in the middle is an angle, and then another side if we have this information, we can find the area of this triangle. Why? Let's see. For triangle, for any kind of triangle, for example, I just draw a triangle randomly. We need a base, we need a height to find the area. So for example, the base, we say this is C. From here to here, the distance is C. The height is H. The area to find the area of triangle equals A equals 1/2 C times H. But right now, it doesn't give us the height. We only know, for example, we only know B and C and this angle A. So how to find the 1/2 C times H, find the area? So if A is given, B is given, can we find H? Yes, because sine A equals opposite over hypotenuse equals H over B. So can we isolate the H, find the H? That means H equals B times sine A. Oh, I see. The B, H equals B times sine A. I can plug in this expression to the formula of area. That means A equals 1/2 C times B or B times C. It doesn't matter. Sine A. So that means if I have a triangle by the given information is SAS, that means side, angle, side. I can find the area of this triangle that equals 1/2 times the side B or C. Just as for example, I say the side C times B and the sine angle A. The A is between C and B. So this is a formula to find the area of the triangle. Okay, so here. Okay, if we have learned, if I have the given information is side, angle, side. So maybe this side, the length is another letter, for example, L or N, it doesn't matter. So the area equals 1/2 times the length of this one, and times the sine A. So the area for the triangle ABC can be expressed like 1/2 BC times sine A, because A is between B and C, or equals 1/2 AB times sine C, or 1/2 AC times sine B. Okay, let's see if we can find the area for triangle by the given information. They gave us that has two sides. One is 5 centimeter, another one is 8 centimeter. And the angle between these two is 121 degrees. So the area equals one side times one side, 5 times 8. Oh, sorry, I forgot 1/2 in front. 1/2 times 5 times 8, sine the angle between these two sides. That's 121 degrees. Use a calculator. That's 1/2 is 1/2, or you just input 0.5. It doesn't matter. Times 5 times 8 times sine 121 close the parentheses. So it's about 17.14. So it doesn't say how many decimals I need to keep. So I keep 2 decimals, 17.14. And then the unit must be centimeter cubed, because 5, the unit of 5 is centimeter, and then times the unit of 8 is another centimeter. That means centimeter cubed. This is the unit for the area. Okay, let's move on to see next part. Apply the law of sines. Find the height of a hill. The angle of elevation is measured. Please pause the video and read the question. So this question is asking the height of the hill. So we use a variable y represent the height of the hill. If we are looking for the hill, the height of the hill, we can put this y in the triangle, this triangle, or this triangle, whatever you want. So let's see the given information. So we know there are 2 points. One is here, one is here. And the angle of our elevation is 32 degrees and 42.1 degrees. The distance between these 2 points is 480 meters. So I found that in this triangle, I have more information. This small obtuse triangle. Why I have more information here? Because at least I know this is one side is 480 meters and one angle is 32 degrees and this angle is 42.1. But you see this angle is 42.1. How about here? So that's equals 180 minus 42.1. That means in this triangle, I have more informations. One side and 2 angles. If I have 2 angles, I can easily this angle is to be found easily, right? So let's say, for example, A, B, let's say this point is C. So by the given information here, I can find the angle C. So let's say angle C equals 180 minus 42.1 degrees equals 83.73. Is that correct? Let's try. 180 minus 42.1. 137.9. So C equals this. How about this angle? B, ABC, this angle. So let's use ABC represent this angle B equals 180 degrees minus 32 degrees minus the angle C here. 137.9 degrees equals, let's use calculator, 180 minus 32 minus 137.9. That's 10.1 degrees. Right now we know 3 angles for this triangle. And can we find AB by the given information? By the law of sines? Yes. And then in this big right triangle, if we know one angle A and we know the hypotenuse, can we find the opposite of the angle A? Okay, so right now we want to find the length of AB. So how to find length of AB from this triangle? This triangle we have more information. So law of sines. So this one, the opposite angle of this length, this side is C. right? It's the C, 137.9 degrees. And the B, ABC, this angle we have learned, we have got from here. And also the opposite of this angle is 480 meters. That means maybe here I'd better use angle B, or it doesn't matter, use this. Okay, so B divided, so B is 480 divided by sine B. Sine B is ABC, sine 10.1 degrees equals C. No, what I'm doing for. Okay, AB. We just assume that the length from here to here is C. So C we are looking for over sine C. Sine C is sine 137.9 degrees. If we are looking for C equals 480 times sine 137.9 degrees over sine 10.1 degrees. So it's about, let's use calculator. 480 multiplied by sine 137.9 close parentheses divided by sine 10.1 close the parentheses. Hit enter. That's, wow, that's a big number. 1,835.0389. So, well, because this is not a final answer, we can just keep 4 decimals. 1835. I have really bad memory. Come back to see the answer again. 0389. 0390. 0390. 0390. So next step, because this is the length of C, is this one. So in this right triangle, in this big right triangle, the relationship between C and Y is sine A equals Y over C, opposite over hypotenuse. So sine A is sine 32 degrees equals Y over C. C is 1835.0390. And then we can solve the Y. So Y equals 1835.0390. I don't need to write 0. 0 is nothing here. Okay. Sine 32 degrees over nothing, over 1. So there's no need to have a line here. And then use the calculator to find the value. So I can just hit enter. I don't want to input the answer. So sine 32. So what is that? It's 972.4 something. So read the question, run to the nearest meter. So if we are looking for the meter, that means just keep the integers here. So integer is 972. 972 meter. So that's the final answer. Okay, let's move on to see next question. Pause the video and read the question. So they provide us the information. This cell tower is 90 feet. And so an observer is here 200 feet down the hill. Measure the angle between the bottom and top tower. So they provide us the angle here is 19.6 degrees. We are looking for the angle here. For example, this alpha is looking for the alpha. So how to find the alpha? So I can move this graph to a big triangle like this, right triangle. It's not that good looking. Let's try a better one. Seems better. So for example, this length is so this one is 90 feet. That's the height of this tower. And from here to here is 200. And the alpha is the angle we're looking for. This one is 190.6. So example A, B, C, D. If we are looking for alpha, so alpha is in this right triangle. So this is 90. If we can find the angle here, let's say this is beta. If we can find the beta, use 180 minus 90 minus beta, we can find alpha. So can we say we try our best to find the beta and then come to this right triangle, find alpha? Yeah, I think we can do this way or use other way. Try this way. And also I have one hint for you. That's beta equals this angle plus this angle. Because in your high school, if we have we have any kind of triangle, we extend one side. Sorry, we extend one side. I don't care any side. The angle here equals the sum of these two angles. Or I extend another side. So this angle equals the sum of these two angles. So if I extend another side, so this angle, I say this, equals this one plus this one. So the beta is created by the extension of this line. So the beta equals 19.6 degrees plus the angle A. Is that means if I can find the angle A, we can find the beta because this one plus this one is beta. And then if we have the sine beta, we can find the beta, we can find the alpha. So let's find the A, angle A, and then find the B, and then find alpha. So if you have better way, you use your way to solve. So in this triangle, they provide us more informations. That's the reason why I'm looking for angle A. So in this triangle we have the opposite of this angle, and then the length of here, we can use the law of sine. So I can say A, that's the length of the A is 200, the opposite of the angle A, over sine A equals 90 over the opposite of 90 is sine 19.6. So from here, we can find the sine A because A is given is 200. I can put 200 here. So sine A equals 200 times sine 19.6 degrees over 90. If you don't understand it, you pause the video and do the cross multiplication and then isolate the sign A. And let's see, what is that? Here. So 200 times sine 19.6, close the parentheses, divided by 90. That's 0.74544. So I keep 4 decimals, 7454. Okay. 0.7454. Okay, what is the angle A? Angle A equals the inverse of sine 0.7454. So use the calculator. Second, sine 0.7454, close the parentheses, is 48.1935, because we round 4 decimals decimal places. 48.1934. Oh, 1934. 1935. Right. About 48.193. 1935, right? Degrees. So if here I have got the angle here, so beta, I can put the beta equals 19.6 degrees plus 48.1935 degrees. So use the calculator. Enter this. I'm so lazy. So plus 19.6. That's 67.7935. I fix the calculator here. 67.7935 degrees. And the alpha is easy to be found because alpha, this is beta, not the angle B, beta. Alpha equals 180 minus 90 minus beta. So 180 minus 90 minus beta is about what? So 180 minus 90 minus, just click it here. Let's see. 22.2. If the question asking nearest tenth of the degrees, I like this one because it makes it easier. That's 22.2. This is 22.2 degrees. So that's the final answer for this question. Is asking the angle of inclination of the hill to the nearest tenth of the degree. So this is the way we solve the alpha. If you have your way, it's easier. You can let me know, and we can use your way because we can save a lot of times. So I think that's the last question of this chapter 7.2. If you have any question, please let me know, and have a good one.